So my name is Tim Hale, and I'm a solutions architect at Cisco and a Thousand Eyes product specialist. My previous experience was working with cloud DNS solutions and also managing IT for a software development studio. So throughout my career, I've been tasked with either transforming the business that I'm working for or helping others do the same. And today I want to take you through some of my experiences working on projects with customers, so migrating and managing cloud and internet-based infrastructure, and also have a couple of slides we're going to look at, but predominantly I want to get into the data and actually have a look at some examples of outages and incidents that might be familiar to the viewers.
Yeah, awesome. So as I said before, I do have a couple of favorite outages of this in the last year. So I'm going to be very interested if you're going to mention them. Are you ready?
Yeah.
Awesome. Then please take it away.
Cool. Okay, so my talk is titled WTF is this cloud-sized hole? Cloud isn't new to any of us, but it certainly presents challenges when we are tasked with managing and maintaining infrastructure that is hosted within it or serving applications over the internet. So firstly, there is a trade-off when increasing your adoption of third-party cloud and internet-based solutions. And this trade-off can be decreased visibility and control. And the challenge here is it leads to increased downtime, could be longer implementation times, and even regular war rooms and finger pointing with partners and providers, which isn't very productive and essentially pulls us off our day job. And I said I only had a couple of slides, and these are my slides. But so now I want to really get into some examples of incidents that may be impacting us in our roles, and how increased visibility can really help streamline some operational workflows and get you thinking about how you might be monitoring in similar scenarios and incidents that are impacting yourselves and the organizations you work for. Okay. Right, so let's start with a DNS outage, so as seen by Thousand Eyes. DNS is one of those systems that has catastrophic impact on a business when it goes wrong, yet rarely are organizations monitoring it properly. So this is an example of an incident that is impacting a well-known application that I suspect most of us have on our phones, Instagram. And Instagram has a dependency on DNS, much like any application or any infrastructure that you're maintaining or managing. So first of all, what we're looking at here is the impact of the outage. So along the top here, we have availability, and you can see that availability drops. And actually, it drops significantly in some regions more than others. So this is the scale of the outage where we see DNS is failing to respond. So of course, the knock-on impact of that is that users or visitors are unable to be served with the IP address of the server that they need to hit, and the application is unreachable. So certainly something that we'd want to take very seriously. So the next step to understanding, what's going on here after we've understood the business impact and the fact that there is an issue, is to really get to the root cause. So the question that I'll need to answer first is this a DNS application issue? Maybe the server has gone down, or there's some other reason why DNS is failing here, or is it a dependency of that server? So, for example, the network. So let's continue to dig into this outage. So moving through to a network specific view. So previously I was on an application layer view. We can see packet loss in the network, and it correlates directly with what I'm seeing from the application's availability. So now I've confirmed that this is in fact a network issue. that is causing DNS to be unavailable and in turn causing visitors to not be able to reach my application. I need to understand the nature of this network outage. So looking at what Thousand Eyes calls the path visualization view, I can see the internet, because here the internet is my biggest dependency. DNS resolution happens over the internet. My application is served over the internet. If I have visibility of the internet, I can more effectively troubleshoot and manage how visitors are reaching my application. So each of these hops represents a point in the network, typically in a transit provider, tier 1 service provider, where I can see the IP address and the network owner. I can see the location that the traffic is traversing. So from all of these locations on the left to ultimately the application location, or in this case, the DNS server location. Now, clearly highlighted here, I can see in red, there's some packet loss. So here I can see that a number of different regions are unable to reach the DNS server, and the issue appears to be that we get to this network ENET, and then all traffic is black holed. So let's dig into this a bit more. And I'm just going to show only these locations, and we're going to get a better understanding of what's going on. So here's ENET. I'm going to select ENET. And I just want to jump forward in time and have a look at what happens when the network health is restored. And that selected node has vanished. And actually, the network looks very different at this time. A healthy network looks very different. I'm even going to search for any networks called ENET in the path, and it's not there. So it looks like this network ENET has appeared, traffic has been black holed, and during the event, that's what the network looks like when it's unhealthy. And when it's healthy, it is no longer there. So I think we can dig more into this because it looks like a routing issue. That BGP controls the flow of packets across the internet, and ultimately, if that traffic starts to go to a different location, then logically it could be BGP that caused this issue. So let's move through to a BGP view. And here is where we start to get a real good sense of the root cause of this issue. So this is the Amazon prefix, which ultimately the IP of the web server resides in. And we see for a short period of time, this network has started originating that prefix. And this is obviously not an Amazon network. So this is a rogue network originating an Amazon prefix, which is a BGP hijack. So we're really starting to piece together the pieces of the puzzle here. And we can work backwards now. So this network announces the Amazon prefix. Traffic gets pulled into the network, where ultimately there's no real route to the intended target in this case, which black holes traffic in the network, and in turn means that the application is unavailable. And if you're at all familiar with some kind of larger historic outages or more interesting outages, you might recognize this as an intentional hijack, and it was reportedly designed to reroute DNS queries and to a bogus server in order to steal cryptocurrency. So yeah, one that's been written up probably on a number of websites, and one that you might be familiar with, but interesting nevertheless to run through from the application layer all the way through to root cause, where we see the hijack and we see how that impacted the flow of packets across the network. So, and just some examples of this. This is quite an extreme example, but probably a more interesting example. So I thought it was worth showing. As I mentioned, I work with a lot of organizations on increasing visibility. And a recent example of something similar that happened to one of my customers. They're an online retail store, so they have a revenue-generating application that uses impact access over the internet, hosted in a major cloud service provider that you would be familiar with. Suffered a full regional outage, where they operate only in their continent. We saw traffic completely black holed in the backbone of this cloud service provider. And that lasted an extended period of time. Then that cloud service provider failed over all traffic to a different continent, causing a major impact to user experience. And interestingly, that cloud service provider had nothing on their status page. So you often find there's all these sources of data out there, and are they valuable? Not always valuable at that point in time, when you really need to answer that question, why are we down, and what is the root cause, and how do we get creative, and how do we find a solution to bring ourselves back online, or how do I report this effectively to a third party which I'm dependent on. So the lessons kind of learned from this sort of scenario is, I believe, is try to be proactive rather than reactive. So I still talk to many of my organizations that I work with that are waiting for their employees or customers to report an issue, which is kind of bizarre in this, when you have a knock, when you have SREs, when you have the infrastructure in place to deal with issues, but you don't have the right tooling in place. Depending on status pages and things is, as I've observed, is not reliable. Another lesson learned is choose the right tool for the job. So monitoring tools like CloudWatch that come from your service providers, they provide great insight, but they are not a single pane of glass for all your dependencies, such as the public internet, such as DNS. And another, I think, lesson learned from monitoring these sorts of with these sorts of scenarios is try and create shareable, easy to digest views of data. So it's really going to make effective root cause analysis and escalations to third parties more easier and streamline that process. Because ultimately, if you've got to communicate to a tier one individual in support, how a major issue is impacting you as a business, often you get that, hey, it's not us, go and look back everywhere that it isn't, and then you have to go back to them. So if you can come armed with that data, you can really streamline that process. And speaking to my customer that had the outage that impacted their retail application, I believe if they had taken that data to the cloud service provider, I think they would have got the kind of workaround in place quicker, because it's quite an extended period of time with a complete outage. And although the rerouting the traffic caused them some headaches, at least they were back online. I think if you are interested in further reading into major outages and the more kind of famous and wider impacting issues that we see on the internet, a good place to look is the Thousand Eyes blog. There's some real detailed analysis of events that you'll be quite familiar with. So if you go to the Thousand Eyes blog and you pick outages, you'll see them all listed. So certainly if one happens in the future and you want to be able to report on it internally, you can go and have a look there, or if you're just interested in reading about them, that's a good resource. So next, I have an example of an event which is likely to be a bit closer to home for many of you. So this is a dependency on a third-party API, which is accessed over the internet. So projects that I'm currently working on involving monitoring in this sort of scenario are maybe monitoring payment gateways, monitoring, even kind of WhatsApp and live chat integrations is another one. So think about, you have your core application, but it's reaching out over the internet to all these different dependencies. And when one of them fails, users complain, user experience is poor, or the application is completely offline. So think about visibility in those scenarios, because the number of dependencies that you might have is surprisingly high, and certainly if there's a lack of visibility there, you could be in trouble in the future. So let's look at that as an example. So similarly to the last example, what we want to try and achieve is the ability to understand the impact of the outage. Initially, we want to have a look at are we online, are we offline, which locations impacted, and understand, translate that to kind of a business impact. We need to do that because we need to prioritize this issue, or give it a priority. Are we paging everyone? Are we waking everyone up? Is this something we can kind of sit on for a while? We also need it to kind of build a story, because if we're going to escalate this to a third party, you're going to get a lot better reaction if you come armed with the fact that it's impacting you in a large way. It's just language that everyone understands, and then you can get into the details of the actual technical side of things after that as well. That'll help you with your escalation. So this is a third-party API which we have a dependency on, and we can see along the timeline at this point it fails, and we are seeing connect errors. We're also seeing other errors, so SSL receive errors. Connect errors point towards a network issue, and again, we're going to need to validate that. Are we seeing issues in the network? So looking at the network overview, we can confirm that in fact there is a correlation. There's packet loss in the network. So this business is, it's impacted. It's a network issue. Who do we pick up the phone to? How do we manage this as an incident? Well, again, we need to understand where in the network this is occurring. So this customer has a data center, and this third-party API is served over the internet. And who knows where it's hosted, right? All we have is the host name, and for all we know, that API has moved around since we first onboarded it, and it could be load balanced across multiple different edges depending on how it's served as well. So visibility here is key to understanding how we kind of triage this and then effectively escalate it. So where's this packet loss hiding then? Okay, so this is our view of the network for this incident. And here we have our different VPS on the left, and we're monitoring out across Amazon's backbone. So let's choose EU West, for example, where we're seeing via Amazon's backbone, so hop by hop through Amazon's backbone, validating Amazon's backbone is clear. We're seeing no heightened packet loss or latency in that backbone. Now we're out on the public internet. So this is Zayo, so a transit provider. Then all the way through that network. And finally, where we're starting to see networks converge, so multiple regions converging into one location here in Chicago, still on Zayo's backbone. And then the host network in green here is Rackspace. So let me we could make this clearer. There we go. There we go. So, and then through Rackspace's backbone. So now we know the application's hosted, the API is hosted in Rackspace, and the entire path from Amazon into Rackspace's network appears clear. But then here, nodes showing packet loss in Rackspace's backbone. So now we understand our escalation path. We need to pick up the phone to the API owner, but we can give them some information. We can say, we've isolated this issue to your hosting provider, so we can not only understand our escalation path because we understand who we've got the relationship with here, who we're paying the money to, who we've got leverage with, but we can arm them with information that they can go to their network provider, their service provider, and say, this is where we're seeing the issue. Of course, there's many incidents we see where it's not the target network that has the issue. A lot of time we're catching issues out on the public internet that are impacting us. BGP, suboptimal peering relationships, regional outages. So the challenge here is that different outages can look the same to us. If we've only got that view from one end where we're only seeing up, down, you've got to look in multiple different locations, and you're not ultimately going to get to find, or it's going to be a challenge to pinpoint where that issue is. So just some examples of kind of how I've been working with customers monitoring in this sort of scenario. Quite recently, I had a customer who had a kind of internal warehousing application. So it's very important for their supply chain. It's performing poorly. When someone was making an order, it checked line by line stock, and they were seeing heightened timings associated with that phase that was causing a backlog of orders. Quite interesting because we were able to observe that the application had an issue, and actually that it was high DNS resolution times that was causing the process to run slowly. And then we had to work through that process of, is this an application issue or a network issue? And although when we were looking at the DNS tests, we saw heightened DNS resolution times correlated with that. We were able to show that the network had spikes in latency at the same time. And we're even able to pinpoint it down to one particular load balancer in that path, that when the traffic traversed that load balancer, only that load balancer was impacted. Now, that path that we were looking at was delivered by 3 different partners. So they had the LAN provider, the WAN provider, the data center provider, and they had many war room scenarios. They'd got everyone onto calls, but ultimately no one had sat there and put their hand up and go, hey, it's our problem. I mean, maybe it's because they didn't know what the issue was, or maybe in that sort of scenario, it's not the sort of scenario where you kind of say, hey, this is on us. There could be penalties for that, for example. So through having the end-to-end visibility, the customer was able to go directly to the data center provider. Data center provider was responsible for the load balancers. They were able to even give them an IP address. Say, hey, can you look at this? So there's no backwards and forwards. Here's the data, and they were able to get a resolution in place quite quickly. So applicable in various different scenarios, of course. And could be cloud or could be traditional on-premise. Could be internet or could be MPLS. Same sort of scenario, really. But of course, as a business, we talk a lot about the internet, talk a lot about cloud, because that's where we're seeing the change and the challenges. So, what kind of lessons did we learn from issues like this? Well, what is your single source of truth? So, don't have a workflow that involves looking everywhere the issue isn't, and booking in a war room with multiple partners and providers when you know that isn't going to be fruitful. If you have a gap, fill that gap. Have a view which shows you all your dependencies, and have a workflow that is optimal in these sorts of scenarios, which doesn't depend on you looking in every tool, every bit of siloed data, until you don't find it, and then you can say, "Hey, it's not us. We've proven our innocence after hours of work." Try to avoid that sort of scenario. Also, historical data is so valuable, because how often are we asked what happened yesterday? Or is the application slower this week or month or even year? If you are in the middle of an incident, maybe something smaller happened yesterday or the week before. Maybe it's happening every Monday. This is information that's really important. A lot of the time, I'm pulled in onto issues that are intermittent. When there's a full outage, it's often easier to troubleshoot, right? But when things are slow and intermittently slow, that's a real problem. And some of these problems are business impacting, but not even the customer doesn't even know about it yet. So having that historical data and always on view is really important. Try not to silo monitoring data. So your multidisciplined employees can be your most valuable. And it's increasingly a skill set that companies are looking for. So giving people access to the data they need to do their job, independent of their job title, can be really rewarding. If you've got an application team that have a dependency on the network, if you can give them that network data, help them be self-sufficient. They're not running the network, but ultimately, if they can have a look at the network and see that the network's fine, they don't pick up the phone to the network team. You're saving some cycles there, and you're also fostering that kind of multidisciplined approach where individuals can really drive a lot more value within your organization. So for further reading on this sort of scenario, I really do recommend again going to the Thousand Eyes blog. We have a couple of blog posts by organizations you'll be familiar with. So Atlassian, big AWS customer, leveraged different tools to get increased visibility of AWS when they were making that big move, and to actively maintain and manage that infrastructure. Also, Intuit as well is another good one. So learn from customers that are doing it or have done it before you. There's a lot of good content out there, especially monitoring monitoring AWS, monitoring other cloud service providers, and other hybrid cloud kind of deployments for visibility in readiness phase, so before going to production, but also operationally once those solutions are in production. I believe Thousand Eyes has a booth, so if stop by the booth, whatever that looks like at a virtual event, and we can share some more information, or at least point you in the right direction if you have some questions. But that's all I had to share today. So thank you for your time, and thanks for the opportunity to discuss a couple of more interesting outages that we've caught.
Awesome. Thank you so much, Tim. So
no worries, thank you.
I hope we're all back now. And exactly on time. I'm very impressed.
Thanks.
Okay, so I'm checking if we have any questions. Someone asked about the blog, and someone else, or the same person, it's not quite clear, replied with thousandeyes.com/blog.
Nailed it. Yep.
Yeah, perfect.
That's an easy one.
Okay. It sounded very interesting. I'll also check out the blog later, I think.
Yeah, there are some kind of marketing stuff on there, like trends, and there's also things about trends. But if anyone's technical, the outages are really interesting, I think.
Yeah, for sure. I was gonna ask you, so, and maybe there will be a couple more questions. So in the meantime, what is the outage that you found most interesting? Maybe because it wasn't that obvious in the beginning, right? You had to really dig in.
I think that the DNS outage that I mentioned earlier was quite interesting because it pointed to the network. But I encounter lots of quite interesting outages. I think The outages that are most interesting to me is when a customer's had a real challenge uh, historically, and they implement the right tool, and all of a sudden it's clear. So I had a customer that was having problems with Google Hangouts, and they'd had it for months, and they kept raising tickets with Google, and that was back in the day when organizations were just taking that step into migrating away from on-premise email and everything to G Suite and to Microsoft 365, and the organization was saying, hey, maybe we made the wrong move. It seems crazy now. It's like, maybe we shouldn't have, maybe we should have kept our on-premise Exchange server. No. But deployed some agents, and we just saw the first hop out into their ISP. There was just latency spikes all over the place. So all those tickets into Google were absolute waste of time, and Google kept bouncing them back, and they were able to just raise a ticket with their ISP and kind of. And everyone was super happy when they got that resolved, because it had been going on for so long. So just when it's really helpful, that's the most rewarding, I think.
Cool. There was a quick question, but the person retracted the question, but I'm going to ask it again on behalf of them. What is your favorite outage? And they put favorite in quotes.
I think I do. Well, I do like the one I went through. So the malicious kind of outages driven by malicious activity are always more interesting, because there's always more of a story, right? So I don't know if it was ever completely validated, but hijacking Amazon's DNS to reroute, to serve a bogus query, to reroute traffic to a fake website to steal cryptocurrency. You could almost write a story about it, or a movie, right?
Yeah, I get the feeling that the stealing compute resources and all of that for Bitcoin mining is like the new thing, the new criminal element of our industry right now. You have to be very careful.
Certainly hot. Yeah, maybe I should start selling security software instead.
I've been trying to buy a graphics card since November.
Those
yes. Bitcoin people ruin everything.
I know your pain.
Lucas, do you have any more questions?
I don't, but if anyone wants to reach Tim, you can use Brella for that. You can start a meeting, and if you want to just use text, you can cancel the meeting, then you can just chat by text. If you want.
Yeah, exactly.
You can just also use the networking if you want to start a meeting with someone.
If you're into that, I don't know if people like to schedule meetings, but you can schedule a meeting and then just use the chat and not go to that meeting, which is also what I do at work. So, so thanks so much, Tim, for joining us on short notice. It was a really interesting talk, and I'm definitely going to check out the blog. And so if you want to go to the booths, to the left of the video, there's a sponsor button, and you can go to that, and then you see all the sponsors, and then you can check out Thousand Eyes, and hopefully Tim will hang out there for a while on the booths. So you can also talk to him. Are you on Twitter or LinkedIn or anything like that where we could reach you, Tim?
LinkedIn is preferable. So yeah, find me Tim Hale. Should be pretty simple. Yeah, under LinkedIn.